Hello everyone, welcome to another episode of Daily Math. Here we have a geometry problem. We have a regular polygon, and this is one of the diagonals. From this point, we have formed two shapes, an orange shape, a blue shape. We want to find the ratio of the blue area to the orange area. Give it a try, then watch the solution. It's not really easy, but you can do it. Good luck. Okay, now I know what you guys might be thinking. This point is not a specific point. We can move it around, take it to the right or left, wherever it is easier for us to solve the problem. But there's one thing to keep in mind. Are we sure that this problem has a unique answer? Because we might be able to move this point around, but are we sure that, if we put it here or put it there, I don't know, does the problem have a unique answer? Well, let's see. Alright, first of all, let's have the circumscribed circle of this pentagon. We want to work out some angles here. This angle, let's call it alpha. It's facing this arc. And then we have this angle, it's facing this arc. It's double in size compared to this one, so this must be 2 alpha. Did you get it? This arc equals this, and this also equals them, because all of them have the same corresponding chords here. It's a regular pentagon. Okay, now let's proceed from here. Let me add this height here, let's call it h1, and another one here, h2, and the side of the pentagon, a. h1 is a times sine of alpha, and h2 is a times sine of 2 times alpha. Now the blue triangle and the orange triangle have the same base here. So the ratio of the blue area to the orange area is base times h2 over 2 divided by base times h1 over 2. So we can simplify this. It will be h2 over h1. And now we replace this. We have a times sine of 2 alpha divided by a times sine of alpha. Again, we simplify and we replace sine of 2 alpha with this, 2 times sine alpha times cosine alpha. It's a formula. Divided by sine alpha. And this will be 2 times cosine alpha. What is alpha? Do we know that? Size of each angle in a regular hexagon is 108 degrees, and as we defined it, it's equal to 3 times alpha. So alpha must be 108 over 3, and that's 36 degrees. So the ratio of the areas must be 2 times cosine 36 degrees. Alright, now that we have proved that the question has a unique answer, 2 times cosine 36 degrees, we can play with this point, move it around to find the answer in another way, maybe in a way that we don't have to use a calculator to find the final value for the answer. Alright, so this is the shape. This is my choice. I have put the point in here so that we have a straight line. You can do it in a different way. Please tell me in the comments how you did it. Now again, let's call this angle alpha facing this chord. This is also alpha facing the same chord. And we know that this is 2 alpha facing these two chords. And what about this angle? It's an external angle for this triangle. It's alpha plus alpha, 2 times alpha. And this is also alpha facing this chord. Alright, now the side length is A, this is also A, and this is an isosceles triangle, so this is also A. Let's call this segment B. This is also an isosceles triangle, so this is B as well. Now this is the blue triangle, and this one is the orange triangle. Again, these two triangles have the same base. So the blue area to the orange area must be, I'm going to take a leap here and say that is A to B. A to B. Please tell me in the comments if you don't understand this. Alright, now let's focus on two similar triangles here. We have this triangle that is similar to this triangle, two isosceles triangles. And we can form an equation based on the ratios. So for this isosceles triangle, the ratio of the base to one of the sides, A to B, is equal for the bigger triangle. For this one, the base is A plus B, and the side is A. And we can simplify the right side. We have B over A plus 1. Now if I multiply everything by A over B, we'll have this A over B to the second power is equal to 1 plus a over b. Now let's take everything to one side. A over b to the second power minus a over b minus 1 is equal to 0. Is this equation familiar to you? Well, let's see. Let's use the quadratic formula. A over b is equal to 1 plus or minus square root 1 squared plus 4 that divided by 2. We can only accept the plus sign because the negative sign will lead to a negative value for a over b. That's not possible. So it's equal to 1 plus square root 5 over 2. That is the golden ratio, or as we call it, phi. And remember, a over b is the blue area over the orange area, the answer. And also remember that it was equal to 2 times cosine 36 degrees. So we also learned something else, and that is cosine of 36 degrees is equal to phi over 2. Maybe we can use it later. Anyway, that was a long problem. That's how I did it. Please tell me how you did it. I first tried to prove that the question has a unique answer, 2 times cosine 36 degrees, no matter where we put this point on this line, on this segment. And then I tried to do it in another way with more freedom for choosing where to put this point, and we reached this answer, the golden ratio. Thanks for watching. See you all, my dear friends, in the next video. Till then, take care. Goodbye.